BINTI PINI and my matrix number is 2023826314.
Hi, my name is NURUL TARMIZI. My matrix number is 2023A6728.
Hi, my name is NABIL HAKIM SHARIZAL with the matrix number of 20236474E.
Hi, my name is AMIRA ZAKRI and my matrix number is 2023X643X76.
Now I'm going to introduce you guys with Newton's law. Newton's law of motion are three basic principles that explain how objects move and interact with force. These laws were introduced by Sir Isaac Newton in the 17th century and are the foundation of classical physics. There are three types of Newton's law: Newton's first law, Newton's second law, and Newton's third law. Now we move to the Newton's first law. What is Newton's first law? An object will remain at rest or continue to move at a constant velocity in a straight line unless acted upon by an external force. 1. A cyclist is coming to a sudden stop. In this picture, the cyclist is coming to a sudden stop by applying the brakes. Newton's first law illustrates here when the bike stops but the rider's body continues moving forward due to inertia. The external force, brakes, acts on the bikes but not directly on the rider. This demonstrates that an object in motion stays in motion unless an external force is applied. The forward motion of the rider is a result of inertia resisting the sudden stop.
The second example of Newton's first law is a soccer ball laying still on the field. In this picture, the soccer ball remains at rest because no force is currently acting on it. It will only start moving when an external force, a player puts, kicks it. Until the force is applied, the ball naturally maintains its state at rest. This perfectly demonstrates the concept of inertia and object resistance to change in its motion. The clean uncolored background helps visualize that no hiding force like wind or players are influencing the ball. Next, we go into the Newton's second law. Newton's second law is the acceleration of object is directly proportional to the net force acting on it and inversely proportional to its mass, and it occurs in the direction of the net force. For the first example, we got a person pushing a shopping cart. This picture shows a person pushing full shopping cart across a parking lot. According to the Newton's second law, the amount of force needed to move the cart depends on its mass and how quickly it means to accelerate. A heavier cart will require more force to get moving than an empty one. If the person pushes harder, the cart will accelerate faster, showing the direct relationship between force and acceleration.
For the second example for Newton's second law is about rocket launching. So a force called thrust is required for the rocket to leave the orbit and enter the space. So rocket generates upward thrust by expelling high velocity exhaust gases downwards, overcoming weight and air resistance. This massive force is essential to accelerate the heavy rocket from rest. As rocket fuel burns, the rocket mass decreases, leading to increased acceleration. Thus, a continuous powerful thrust ensures the rocket to space. For the next one, we are going to talk about the Newton's third law. But before that, let me talk to you about the definition of Newton's third law. Newton's third law stated that there is an equal and opposite reaction. In other words, when one object exerts a force on a second object, the second object exerts an equal force in opposite direction on the first object. So the first example is about swimming. So Newton's third law states in every action, there is an equal opposite reaction. Hence, in swimming, the swimmer pushes the water backward, which is an action, and the water in return pushes the swimmer forward with an equal opposite forces, which is reaction, propelling them through water. This continuous application of pushing water backwards and the water pushing the swimmer forward that allow movement to occur. So without this reactive force from the water, the swimmer would unable to move.
An example of a Newton's third law is a balloon releasing air. When a balloon is released, the air pushed out back for the action, and when the escape air pushed against the balloon, propelling forward is a reaction. This equals an opposite direction force cause the balloon to fly in the opposite direction of the escaping air. This is a classic example for the Newton's third law where the motion is caused by opposite force acting on the different object. If no F force, there will be no force to push the balloon, so it will stay still, and demonstrate the action and reaction force act on different objects always come in pairs.
For the conclusion is, networks have a three laws of motion help us understand how and why things move. The first law says that an object will stay still or keep moving at the same speed and direction unless something pushes or pulls it. The second law explains that if you push something harder, it will move faster, especially if not that heavy. The third law tells us that for every action, there is an equal and opposite reaction. If you push something, it pushes back with the same force. Together, these laws explain the basic rule of motion we see and use in everyday life. That's all from us. Thank you for watching. Bye bye.